Cinder and Glance storage for OpenStack. And stick around for the Q&A. We have Brett Nyber here. He's an engineering manager in Red Hat Storage, and we'll have other people join as well. Ben Cohen's here too, so stick around. Please take it away, Brian.
Okay, hi. So this is a Ask Me Anything, but before you ask me, I'll lay out some things that you could ask me about. I'm a senior software engineer at Red Hat, and I'm working in the product and technologies group on OpenStack. And specifically, I'm working in the Cinder squad for the storage delivery focus group. I've been active in OpenStack since Folsom, which is like 2012. And I've been a core contributor to Glance since Mitaka, which is like 2016. And then I've been working on Cinder and been a core on Cinder since 2019. And what a core contributor is just someone who can approve changes to the code base. And I'm currently the Cinder PTL, which means I just, well, it's an elected position and I sort of manage the project. But of course, nobody actually reports to me. So the management really only happens with everybody cooperating. So it's a kind of odd thing. I've been at Red Hat since last week of September 2018. And my primary duties are upstream, which is nice. So I'm working mostly on OpenStack, but I also do work on downstream bugs, which is in the Red Hat product that's built out of OpenStack. And what's great about working at Red Hat is the upstream first attitude towards fixing things. Because we know when we fix things upstream, eventually the fixes will be downstream too. So we'll get them. That's a kind of obvious point, but it's really nice to be working at a place where you don't have to constantly convince your managers about that. Okay, and too fast. All right, so what we'll discuss today, just to give you a quick idea, is we'll talk a bit about OpenStack and OpenStack development. And we'll talk about Red Hat OSP, the OpenStack platform that Red Hat has as a product. We'll talk a little bit about sausage making, and then Glance and Cinder. Then I'll focus a bit on the Cinder drivers, and then we'll talk about OpenShift, which is why you're here, and then Cinder CSI and Ember CSI, and then it'll be time to ask me anything. Okay, just to sort of kick things off, why should you care about Cinder and Glance? So they're core components of OpenStack, and OpenStack is the basis for the Red Hat OpenStack platform, and the Red Hat OpenStack platform can run OpenShift on a shift on stack configuration. And Red Hat OpenShift is why there are OpenShift Commons briefings. So that brings us full circle to why we're here. All right, so let's talk about OpenStack. So OpenStack's an open source project for building a private or public infrastructure as a service cloud that runs on standard hardware. So you're using virtualized resources to build a cloud. So it relies on virtualization software. It also relies on some kind of base operating system. And for more information, you can just do openstack.org. And that'll bring you to the main site. You can find out all sorts of stuff. All right, so it's infrastructure to build a cloud. So what exactly is a cloud? And I sort of apologize. I used to be a college professor, so I can't help myself getting into definitions of things. But there's a NIST special publication that lists 5 essential characteristics of a cloud. So the key aspects are it's on-demand self-service, you've got broad network access, there's resource pooling, or multi-tenancy, so everyone's sharing stuff, even though they might not know it. They have this illusion that they have their own resources, but they're actually all shared. You have rapid elasticity, and you've got some kind of way to measure the service. So you can either charge or bill or figure out how to build out your infrastructure. So it's a lot of stuff that has to be coordinated is the main point. So OpenStack architecture is that it's divided into a lot of projects, and they provide different services that you need to run a cloud. The major ones are the compute service, which is called Nova. And that's what builds the actual VMs, the virtual machines that are used. We saw networking is really important. everything's got to be networked. So the service that does that in OpenStack is called Neutron. Then in order to boot the VMs, you need some type of image to boot from. So that's where Glance comes in as the image service. If you want to have persistent storage past the ephemeral life of a virtual machine, you need something. So that's where Cinder comes in as the block storage service. And then since everybody's sharing all this stuff, we need some way for people to authenticate and be authorized. So the keystone is the identity service. And then there's also the object store that comes with OpenStack that's called Swift. So basically the OpenStack architecture is just, you've got a bunch of projects and they provide the services via REST APIs. And there are a lot more projects than the Dirty Six. Dirty Six is what Graham Hayes, who's the PTL of Designate for a long time, calls the core projects, because the core projects get kind of special treatment. But there are probably like 48 projects making up OpenStack at this point. And if you want to see the APIs that they expose, you can just type in OpenStack API reference in DuckDuckGo, and that should bring up the main page for all the reference guides. And you'll see there's a lot there. All right, so how code gets into OpenStack. So developers contribute code by posting a Gerrit review to the appropriate project. I just want to talk about this a little bit because every open source project has different ways of doing things. And so this is how we do it in OpenStack. So what's there is a screenshot of what one of these reviews looks like. But if you want to actually see it and not have to squint at your screen, you just type in review.opendev.org and then / and then the review number. So this one is 730183. If you want to look at it, because I think everybody's probably working from home and has access to their computer. But I'll also have screenshots of parts of this so you can see. Now, as you scroll down the review, you see the list of names. Everyone who leaves a comment gets recorded on the review. And if you click on the names, it'll pop open what their comments were. And this is how it goes. So what'll happen is somebody will post a patch. So in this case, it was me. So I'm using my own stuff so I can make fun of myself. And you can see people leave comments either saying it's good or it needs something to be corrected. And then that all gets worked out in the patch. So you have people openly reviewing all the code. And what's interesting is the design work is done in the same way. So features would be proposed as specs, and those are just restructured text documents that are posted in Gerrit, just like the code, and get reviewed by the project community. So if you want to look at an example of that, it's the same base URL, the review.opendev.org, and then this one's 733555. And it's default volume type override. So this is a spec that just got approved maybe last week. And there, you'll be able to see on there, there's a lot of discussion around the API and what it should look like, what it should return. You know, so you get to this thing about byte shedding. So byte shedding is this idea that when you're trying to design something, you don't want to spend a lot of time arguing about the color of the byte shed when you're ignoring more important things like whether it's being built in your driveway or whether it's being built to the side of the driveway. So I'll just toss it out there. So if you want to see the OpenStack specs, this is how pretty much all the projects do things. You can type OpenStack specs in DuckDuckGo and you'll see all the approved specs. But the way they get proposed and the way they get reviewed is just like code. All right, and then how the code gets into OpenStack. So we saw people review the code. Before most people will review it, when you post a patch, there's an initial check that's done by the continuous integration system. So it'll run a set of tests and either post a +1 saying, yes, this has passed, or it'll post a -1 saying that something's failed. And pretty much if your patch is failing, nobody's going to review it because that -1 is a sign that something needs to be fixed immediately. and then people will start to look at it. So you get that initial check, and then other contributors will review the code, and then you'll probably go through a series of revisions. So that patch I had up earlier, I don't know, went through like 12 revisions or something. So it's back and forth. And then you come to the Zool gate. And then the gate is different from the check. So with the check, you just take the patch that you've got and see whether it works. When it's time for something, when code's been approved, it's got to go through this gating process, because what happens is you need to take into account the fact that all the other projects are doing the same thing at the same time you're doing it. So we don't want to test, so that patch that I had up for Cinder, we don't want to test that against Nova and Glance the way they are right now, because by the time my patch actually lands, Nova and Glance may have also landed patches, and so they may be different, and then there's no guarantee that the code that I submitted that was working against the old Nova and the old Glance will work against the way they are when my patch actually lands. So it gets a little complicated, but there's an integrated gate, and what it does is it takes into account all the patches that are happening for the projects at the same time, and then it stacks them up and runs them against each other. And as patches fail, they get kicked out, and then all the ones that remain get restarted. But the basic idea is that you want to make sure it's always the case that when a patch lands, we've got a state where everything has passed across all the projects. So you can see this in action if you go to zool.openstack.org. By default, it should open up to the status page for Zool, and you can just see all the jobs that are currently running. And on the left, you'll see the checks, and then in the middle, you'll see the gate. And if you look for the integrated gate, you can see how they're stacked up and how they're linked. And if you watch, one will go red, and then stuff will disappear, and then things will be rerun. So it can take a very long time for things to eventually get through the gate. But the key thing is that we have some kind of quality control, and that's very nice. Okay, so here's an example. If you look at the well, this gets displayed on the right side of the Garrett review, but I took it apart here so that you could look at them. So we've got the Zool check, and so those are running the unit tests, and then you can see there's a bunch of tests. You can see there's one failure in there, but it's a non-voting job. So some of the jobs vote and some don't. So jobs that are either unstable or kind of experimental will be non-voting jobs. And then if they fail, it doesn't count against you as far as Zool is concerned. But one of the reviewers may look at that and dig a bit deeper. So the fact that Pilot failed, it might be because of some other patch, or it might be because I'm not doing something good on my patch. So you might want to look into that. And then on the right, you see the Zool gate. So this is the integrated tests before the code is merged. And I guess the thing I wanted to point out is you can notice the times on these. So if you look on the left, way at the bottom, there's the Tempest Slow Pi 3. Right, so that test took 2 hours to run. So these are pretty long running tests. And basically what's happened is an OpenStack cloud has been deployed, and then a whole bunch of tests have been run against it. Yeah, so I should say what Tempest is. So Tempest is the OpenStack integrated test suite, and it's a battery of tests that hit the APIs for the major projects. And basically the way it gets run is Zool builds an OpenStack cloud and then just runs these tests against it. And then you see what happens. And sometimes things pass and sometimes things fail. And sometimes things will fail, not because there's bad code, but because you start to get into deployment issues. So there may be resource constraints, or weird networking things can happen where a network can fail. Or, it can just be, noisy neighbor kind of stuff on VMs. You never quite know. So it's always an adventure running those things. Although we'd like it to be deterministic. Okay, I think Okay. All right, so talk about OpenStack and OpenStack development. So now I'll talk about the OpenStack platform that's brought to you by Red Hat. Okay, so what we've talked about so far is all very nice, but you as a consumer really don't want OpenStack, right? What you want is the OpenStack code plus some virtualization plus an operating system, and you'd like it an easy to install package instead of a whole bunch of distributed code repositories. So key thing is it's not enough for the OpenStack code to be solid. It's going to have to integrate well with the other OpenStack components, and then also whatever virtualization layer is being used and whatever operating system you want to run this thing on. So when we get to Red Hat OpenStack platform, it's a distribution of OpenStack that's been packaged and tested to work with Red Hat Enterprise Linux. All right, and so that brings us to making the sausage. So way on the left, we've got OpenStack. So that's the code we've been talking about. Then in the middle, we have this thing called RDO. And then way on the right, way downstream, we've got the Red Hat OpenStack platform. So let's talk about RDO for a minute. So RDO stands for the RPM distribution of OpenStack. So it's an independent project that's sponsored by Red Hat. But if you go to rdoproject.org, you can get more information about it. But basically, it gives you a community distribution of OpenStack. So anyone can go to the OpenStack code repositories and grab the source code, but then you've got a lot of work to do to bring it all together, to gather all the dependencies and install it and make it work. So what RDO does is builds a distribution so that you have RPM files that you can use to deploy OpenStack. So the RDO distribution deploys a cloud using this thing called OOO, which you may have heard of. It's OpenStack on OpenStack. And that itself is another OpenStack project. So what it does is it provides an OpenStack undercloud. And then the operator uses this small undercloud to deploy an overcloud, which is all the nodes, the API nodes that users will interact with. And that gives you the production cloud that you can use. So what RDO does is it packages OpenStack and RPMs, and then it tests them using the CentOS operating system. So packaging is always an adventure because we have several components, or at least 6, and we need to make sure that they've got compatible versions of their dependencies. And then once you're onto the operating system, you have some operating system packages, you may have some differences. So it's important that everything be tested. So what happens with RDO is it uses its own Zool instance, so its own continuous integration system to do the integration testing. So unlike upstream, where what you deploy is just the OpenStack code, what RDO does is it installs the RPMs that have been built and then runs the Tempest tests against that to make sure that when you've installed those packages on CentOS, that everything works the way you expect. So it's a key ingredient in getting all the way downstream to Red Hat OpenStack platform. And it's, doesn't sound that big a deal, but it is very difficult to do this kind of packaging and testing. So my hat is off to the
I think we may have lost Brian. Brian, can someone confirm that you can hear me?
I can hear you.
Thank you.
Yeah, I think it was Brian.
All
I
right.
think he just, yeah, still sharing his screen somehow.
Yeah. All right. So while we're waiting for Brian to come back, thanks, Justin. So Brett, you and I saw Sean's online. Thanks, Sean, for joining us too. Actually, a lot of great people are on right now. So initially, what work have you been working on with OpenStack, Sean? If you're there. Otherwise, I'll pick on you, Brett.
Yeah, I mean, for us, it's mostly business as usual, making sure that we're continuing to support OpenStack from a storage standpoint and trying to figure out what's going to happen with 17 so that because we're trying to figure out our own roadmap, and we've had to, with supporting OCS every quarter, we've had to kind of pick and choose what we can actually ship as far as our HCS. So.
Right. So if anybody's on that wants downstream features in OCS or OpenStack, now's the time to speak up. Or not. Now you know who to go to. So we're still waiting for Brian. All right. Okay.
Yeah, hey, Karina, can you hear me?
I can.
Hello.
Hello.
Hey, Sean.
Thank you. Hey, Brett.
Hey.
I know I was tuned out doing something else there for a sec after we lost Brian. Oh, and Brian's back. Okay, so I don't have to filibuster or tap dance, but just I'll give the quick answer to the question that was posed. As the product guy for OSP Ceph specific stuff, I am in pursuit of formal OCS support, productization of OCS with OpenShift on top of OSP. Now that's a loaded topic, and I think Brian's going to talk about some of the technical stuff around that. So I'll leave that to him. But we are in hot pursuit of providing OCS support in a productized way on top of OSP. And there's a storage can be provided to OpenShift today just through straight up OpenStack services, Cinder, for example. And we won't take that away, right? There'll always be that escape hatch to use the native storage services. But OCS will be, we are pursuing support for productizing OCS on OSP over the coming months. I'll leave it at that. If anyone has any specific questions about that, you can come after me.
Okay, well, let's let Brian finish, and then it'd be great if we hear more about all. Go ahead, Brian. Do you want to share your screen again, or we can't hear you?
Okay.
There you go.
How about now?
Yeah, perfect.
Okay, thanks. All right, sorry about that. Just in case anyone cares, I'm running Fedora 32 on a Lenovo P50, and every so often it just dies. And I get nothing in the logs that are of any use. Okay, but so anyway, this is a good place to pick up. So we're at Red Hat OSP finally. So it's an enterprise-grade distribution of OpenStack, packaged for Red Hat Enterprise Linux, and it's tested thoroughly. So both automated testing and also manual testing for key features. And the manual testing comes in because there'll be new things for which there are no tests. And it's always a goal of the QE people to turn these manual tests into automated tests for the next time. So that's a constantly ongoing thing. Lost my... Okay, I forget exactly why I popped this in here, but the Open Infrastructure Summit is where OpenStack and the other products of the OpenStack Foundation. So Zool, which is the gating system that's used with OpenStack, is also its own product that's sponsored by the OpenStack Foundation. And as you can see, it's used by RDO and it's used by various other enterprises to do their continuous integration. The summit was supposed to be held in Berlin in October, but it's going to be held virtually. So I'm bringing it up because there's no cost to attend. So if you're interested in OpenStack, that's a place to go and see. So it's openstack.org/summit/2020, and that'll bring you to the page where you can register and get more information about it. Now, the OpenStack PTG, which is the project teams gathering, was also supposed to be held in Berlin, but that's going to be held virtually also. And that's where all the design discussions for the next release of OpenStack take place. So I think it's going to be around that same week, although they haven't announced the exact dates. They may switch it slightly so that there's not as much overlap, because the virtual conferences are, I don't know, it's pretty exhausting when you go in person, but to be like on your computer for like 6 hours at a stretch is pretty rough too. So they may switch up so that the design sessions aren't being held at the same time as the regular summit. All that stuff's being worked out. Everybody's trying to be flexible in these pandemic times. But anyway, so something to keep an eye on if you're interested in any of the design things that are going on or features that would be useful for OpenShift to show up in OpenStack. This is the place to be. So openstack.org/PTG. If you go there now, I think it brings you to the page about the PTG that we just had at the beginning of June. But anyway, it's free and it's a way to get involved and have some influence. Okay, so back to Red Hat OSP 16. So 16 is the current release. It's built on top of the OpenStack train release. So 16.0 was released back in February this year, and that was built on RHEL 8.1. 16.1 is imminent. So the beta's been out since the end of May, and it's built on RHEL 8.2. The GA is going to be very soon, so probably within a week. So something to know. And just something about the OpenStack releases. OpenStack is on a 6-month release cadence, and the releases have names that have been alphabetical since Austin, which was the first release. And the ones, I don't know why Victoria doesn't have a date. Oh, I guess because it's happening still. So the OpenStack releases that have been happening, we've got Train that was delivered at the end of October 2019. Then Usuri was just delivered in May of this year. And the stuff we're working on now is for the Victoria release, which is going to happen in October. I'm bringing this up because OpenStack versioning can be very confusing. So what OpenStack is, it's a coordinated release of a set of deliverables, right? At least 6 and possibly a lot more. And each of those deliverables has its own version number. So the actual release of everything is referred to by the name. So for Train, we've got Nova at version 20, Glance at version 19 because it was introduced the next year. And then we've got Cinder at version 15. And then Red Hat OSP is at version 16. So I'm just mentioning that because it gets very confusing when you're trying to coordinate the release numbers with the version numbers. So Red Hat OSP 16 is built on OpenStack Train. For Red Hat, it's a long life release, so it's going to be supported for a long time. Now, Red Hat used to do some long-term releases and then some short-term ones. And what it turned out was it's difficult to hop onto a short-term release and then have to upgrade right away. So the idea is we're going to keep these longer-term releases. So we're going to be at OSP 16 for a while. And it's built on Train, but you can see upstream, we've already delivered Usuri and we're working on Victoria. So future versions of 16 may contain some U or V features, but it will primarily be Train. And part of the deal here is the idea to keep the OpenStack platform in closer sync with Red Hat Enterprise Linux. All right, so another weird thing about OSP 16 is the Python version. So Train is the last OpenStack release to support Python 2.7, which, as you probably know, went end of life, I think in January this year. Now, Red Hat OpenStack Platform 16 only supports RHEL 8. And in RHEL 8, the default fully supported version of Python is 3.6. So Red Hat OpenStack platform for 16 only supports running on Python 3.6. Upstream, slightly different. In Usuri, it's 3.6 and 3.7, and then Victoria 3.6 and 3.8. The weirdness there is that OpenStack supports the versions of Python that the major releases support. And RHEL is supporting 3.6, so RHEL, CentOS, Fedora are all supporting 3.6. And then Ubuntu Focal is supporting 3.8. So that's what we've got there. All right, so anyway, that's all the background stuff about OpenStack. Let's talk a little bit about Glance. So Glance is the OpenStack Image Service. So it gives you services and some associated libraries that allow you to browse, share, distribute, and manage disk images, and then other closely related media that you would use to initialize computing resources. And it also does this stuff with metadata definitions that I won't really talk about. It provides a catalog of them basically. But if you want more information about Glance, it's glance.openstack.org. Will take you to the Glance documentation. And then the code is in the opendev.org repositories. So opendev.org/openstack/Glance will get you to the Glance source code. And it's also mirrored on GitHub. So some recent developments in Glance. We've got interoperable image import. And what that does is the old-fashioned way of getting images into Glance was you just sort of pushed them to Glance. But depending on your configuration and what's going on in your cloud and whether it's public or not, you may wish to take a look at these images before you let them loose. So with image import, there's a series of plugins that can process uploaded image data and do whatever the operator wants to screen the images perhaps before they're actually made available for people to boot in VMs. It's also a recent development. Glance used to just have one store that you would pick, that the operator would pick when you set up Glance. Now Glance has the ability to have multiple stores, so you can have different tiers of storage or do whatever you want with that. And then currently there are enhancements going on for the distributed compute nodes or the edge deployments. And the idea is to give Glance the ability to move image data closer to where it will be used. Because the images tend to be rather big and it takes time to move things around. So that's what's been going on with Glance. As far as the community goes, the current PTL of Glance is Abhishek Kakane, who's at Red Hat. And just an interesting kind of statistic, 75% of the core team on Glance is from Red Hat. And if you want to contribute, just go to glance.openstack.org, and somewhere near the bottom of the page, you'll find the Glance contribution guidelines, and there's information about when the Glance meetings are and what you can do. All right, but now I'd like to talk about Cinder. So Cinder is the OpenStack block storage service. So it implements services and libraries that provide on-demand self-service access to block storage resources. And it provides software-defined block storage by abstraction and automation on top of traditional back-end block storage devices. So the docs, just like with Glance, are cinder.openstack.org, and then the code is opendev.org/openstack/cinder. All right, so quick look at the general architecture for Cinder is you'll have the Cinder API. So there's a REST API that you can interact with using some type of client, either the OpenStack client, or you can write your own, or you can use a Python Cinder client. There's a scheduler that schedules the builds of the volumes. Then there are volume services that interact with the actual storage backends via these drivers. And then what that enables is self-service access to block storage resources using the API. Now, drivers are kind of important. There are over 70 drivers right now in the Cinder code repository. And what the drivers do is they mediate between the block storage API, which gives a constant or a consistent interface to end users, and the particular storage backends. And so, the idea being that you've got a single API that you use, but you can get access to storage that's on different backends that will have different properties depending on what kind of hardware you've actually deployed. And that's up to the operator how much of this wants to be exposed to end users. Supported drivers have functioning third-party CI systems that run on every patch that's proposed to Cinder. So just as we saw earlier that Zool runs these CI jobs every time somebody submits a patch, for each of the drivers, in order to be included in the source code repository, you've got to be running a functioning CI system that also runs all the same tests against your particular backend. And so this way we have some kind of knowledge without having to purchase the hardware for every single vendor. We have some kind of knowledge that changes that are being made to Cinder actually aren't breaking anything else, more or less as much as you can tell from testing. So the third-party CI gives you additional information when patches are being reviewed. So they don't get to vote, but they do record whether they've passed or failed given a particular patch. So in the review that we were looking at earlier, this is just an abbreviated list of some of the third-party CI. But you can see, starting with Cisco, because they're first in the alphabet, you go C and then all the way down to VMware, and the ... in the middle, because there's approximately 70 jobs like this that are going on. And you can see for each of these, there'll be a particular driver, and there'll be fiber channel and iSCSI for some of them, just various things. And they can record successes or failures depending on what's happened on the CI. So just an additional check for quality control. So what the third-party CIs run are the OpenStack integration test suite, which is called Tempest, plus additional Cinder-focused API and scenario tests that are contained in the Cinder Tempest plugin. So basically, this gives us the ability to add extra integration tests for drivers to focus on particular areas of functionality for particular configurations, because part of the problem is everything in OpenStack is configurable, and Cinder is very configurable. So how many backends you're running at one time, there are various options that can be exposed or turned on or off, and so there are just lots of different. If you're pessimistic, you say there's just lots of ways that things can break. So what we want to have is some kind of good tests so that we can catch those things before they get downstream. And adding the integration tests, one thing you may wonder is just, why don't we have more tests? And we're adding them. It's an important thing for stability, but it's also not overly easy to add them. So the example I've got here, if you take a look at it, it's testing one simple thing, but it took about 100 lines of code to get the test together. And then if you look at that patch, you can see that it's been approved, but it still hasn't been able to pass the gate because of just various weird things that are happening. Not related to that patch in particular, but just like the last thing I saw was a resource issue. So there was a network that was trying to be used, but it was already assigned somewhere else, and so the tests failed. But anyway, Cinder has drivers. We have extra third-party continuous integration tests that are being run on them. So we try to keep the quality of the drivers pretty high. And the drivers are what interact with the backend. And which brings me to the Cinder mascot, is the horse. The main thing that you can see there is the horse's back end, because the actual back ends where the stuff is stored are really the most important thing about Cinder. Okay, so now let's talk about Cinder and OpenShift, which is what you're really here for. All right, so you've probably heard of the container storage interface, which is a specification so that a storage vendor can develop a single plugin that's going to work across all the container systems that support that standard. So the idea is that storage vendors don't have to touch the core code of the container orchestration system, like Kubernetes, in order to get their stuff to work. They just need to build a particular plugin that meets this interface, and then they will be able to provide persistent volumes to the container system. So with Cinder and CSI, when you're running OpenShift in a shift on stack configuration, then Cinder is going to be available to you because it's there in the OpenStack cloud. Well, theoretically, it's available to you. What will make it actually available to you is the Cinder CSI plugin. So it meets the CSI standard, but it interacts with the Cinder API. So what's nice about that is whatever storage backends an operator has configured for Cinder can then be used to serve persistent volumes in OpenShift. So that's a nice connection. All right, then what about when you're not running OpenShift on top of OpenStack? You can run Cinder in a standalone mode. So the OpenSDS project takes this approach, and basically it's Cinder without authentication, but it's the entire Cinder system that we saw earlier. So you've got the API, you've got the scheduler, you got the message bus, you've got the various volume services, and then some things I didn't show on that chart. There's a backup service if you want to deploy that. So this is a pretty heavyweight approach if you want to have Cinder. If you want to have persistent volumes for your containering services run through Cinder. So recently, we've got this library called cinderlib, and it's a Python library that allows Cinder storage drivers to be used outside of Cinder. So it's a deliverable of the OpenStack Cinder project. So you'll find it in the opendev.org/OpenStack/cinderlib is where the code lives for that. And version 2.0.0 was just released last week. So what it does is it removes the database management system, the message broker, the block storage API, the scheduler, and the volume manager layers, because you don't really need any of that stuff. What you really want is just access to the driver that allows you to get access to the storage backend. So what's nice about it is that we have a lot of tested driver code in Cinder, and those things are sitting around and we might as well use them. So it allows vendors to reuse driver code they've already written and have already tested running with Cinder, and then they can reuse it in this new context. So for instance, Hitachi and Dell EMC just added new drivers for the Victoria release. So those have merged recently. So we've got over 72 drivers. So in order to use this, there's a thing called Ember CSI. So that allows you to take advantage of all the tested driver code from Cinder. So it uses cinderlib, but Ember CSI is what presents the CSI interface for you to use in the container orchestration system. And then it interacts with the drivers from Cinder in order to actually do things in the storage backends. And if you want to see more, it's ember-csi.io will bring you to more information about Ember CSI. Okay, thank you. So that gives you a rough idea how OpenStack works, what we're interested in, and then sort of brought it all the way back to OpenShift with the Cinder CSI and the Ember CSI. But now it's time to go ahead and ask me anything. I can't see anything, so you have to just bear with me.
Thanks, Brian. Sean, Brett, if you're still around, and I know Ben is, please, anybody put your questions into the chat or on any of the channels. Sean, was that you trying to jump in? I know you and Brett had some questions too about downstream.
Well, I'm interested in 17, but I know that's been pushed off a bit. I don't know if you have anything to say on that. Brian.
Yeah, I'm going to stop sharing my. I'm afraid to
I
stop
was going to
sharing my
mention that you
screen,
could do
actually.
that. Yeah, then you can see.
Yeah, so with 17, I can tell you everything I know about it, which is pretty much nothing at this point. So there's some rumors that I probably shouldn't go into. So yeah, I don't know. It's not clear whether it's going to be based on W or not. Um, yeah, and that's basically
Right.
it. I've heard a rumor that it might be RHEL 9 based, which would mean that it would depend on the RHEL release cadence.
Right.
But I really don't. I want to stress that I don't know.
Okay.
I'm just speculating. So yeah, it's been yeah. I think people are waiting to see exactly how the 16 experiment works out, where we're going to stay focused on the train release and see how far that gets
Yeah.
us.
Right.
Yeah. So, sorry, I don't have a better answer.
Do you have
Yeah,
more
and
of a
not that
guess?
it's directly germane to this discussion, but since you guys brought it up, there is a degree of, shall we say, orientation toward the needs of telcos, right? That's driving some of this stuff. So there are initiatives internally that are looking to build out the telco stack, or the telco stream, which has its, basically has its true north as the combination of RHEL and OSP, and the other pieces sort of working to fall in line with that in terms of release schedule, timing, extended support timing, all that stuff to make the experience at the telco customer in particular, to improve the customer experience there, and with respect to viewing the stack as one Red Hat, not worrying about whether OSP and RHEL and Ceph all have different ELS programs and things like that. So some of that is influencing what Brian was sort of tiptoeing around there. There's not a lot that can be said at this point in a full-throated way, but just to to let folks know that that's where some of that influence is coming from, and there's we're looking at the plans over the 12-month plus horizon to accommodate that kind of thing. So it's all goodness from my point of view, anyway.
So we have some questions. You want to talk about home servers? So to get OpenShift on OpenStack at home, what do you recommend? PackStack, RDO, Fedora? I think you're muted, Brian.
Yeah, I'm thinking.
Anybody else also running this at home right now?
Yeah, I'm not running OpenShift on OpenStack at home, so I'm not the good person to ask for this.
What about OpenStack at home?
Well, I got to tell you, so part of, like I hinted at before, being the PTL, what I wind up doing is I've got to manage people who don't actually work for me, and then I got to do all the stuff nobody wants to do. So a lot of time I need to run DevStack actually, so way upstream, because that's what's actually running in the gates that break and then need to be fixed. So I'm really like I'm running like the worst possible OpenStack experience. So I can't really recommend it because I'm doing all that stuff that nobody wants to do, which is, building everything from source. So sorry about that, but RDO is quite good.
I was wondering, Matthias, are you running this at home? I think of anybody, you would probably not to really call it out.
No, not at home. Just to support complex cell and not enough power here.
Yeah, this would make an excellent blog post. Just for you, Ben.
My team actually uses Linode or Linode, however you want to pronounce it, for a lot of cluster setup teardown. They're running OpenShift that way. I don't know for sure if anyone's running OpenStack that way, but it's been pretty useful. It's much less expensive than AWS, although you have to. You still have to find a way to get it expensed.
Has anyone tried running OKD on OpenShift yet? The OKD 4 release went out a couple weeks ago. No, there's a silence
That's a
there.
great question, right?
Yeah, because we're running an OKD deployment marathon on August 17th, and I think August Simonelli has stepped up to do a deployment. So we're going to live deploy on all the different platforms, and we were looking for someone to do it on OpenStack. But I'm curious whether it's ROSP or RDO. Doesn't really matter. OKD4 uses Fedora CoreOS, and you just have to have the images available. And I know a few people have attempted it on their home stacks, but I don't know. I haven't heard yet if anyone's done it and is willing to do it publicly in this marathon of deployments on August 17th. So if someone out there in OpenStack land wants to work with us on that challenge, that would be lovely to have one of the hours in that marathon be an OpenStack deployment for OKD4. And it is the same deployment process as OCP. So it just uses a different set of images.
Diane, do you have a link to that handy?
To the marathon page?
Yes.
No, not yet, but it will be linked to okd.io. We're putting up the schedule for the marathon on later. I'm developing it today, and it should be published tomorrow. So there will be a landing page there.
Cool. I wanted to also point out that next Monday there's a session on PackStack. So that is at 8 a.m. Pacific, 11 Eastern, to the person that was asking about OpenShift on OpenStack. I put the link in chat also.
And if anybody else wants to do OpenStack related, I think Amy Merrick is going to be hosting that AMA for me, as I want now to find a vacation slot and make other people do my work for me. But Amy's going to try and start scheduling a number of OpenStack related topics as well. So look for more OpenStack content in this time slot, either on Mondays, Tuesdays, or Wednesdays. And we'll be seeing if there's something that any of you want to talk about related to OpenStack or new releases or features, just let us know and we will give you the podium.
So I recognize a lot of names that would be good for that. So hopefully,
yeah, there's a lot going on. I'd love to get an update on Ironic and a few other things. So hopefully that will happen in the next little while.
And maybe 17. I know Brett's really interested.
Yes, this is the thing. You ask a question, you end up being the speaker at the next one of these. You haven't figured that out yet. That's might be scaring everybody. But yeah.
Nice. All right.
So,
go ahead.
Just if there's any additional resources, Brian, that you might have to point us to the main landing page for all of this.
Oh, yeah, I should put this somewhere. So
you can just navigate there.
yeah, this is in my Red Hat Google Drive. So I know I can share with all the Red Hat people, but I don't know that it can go outside.
Yeah, this is an external facing thing. So if it's not public, and no, I was just thinking the landing page for ROSP would be a good link to end on.
Oh, okay. Let me see if I know it. It's in here somewhere. All right, let me look real quick.
And again, thank you to Brian for giving this deeper dive into Glance and Cinder and all the storage that's going on upstream for OpenStack. I know we could get into a lot more. And thanks for Brett and Sean and everyone else for being here. Ben. Thanks for all your links. And can't wait for all the new series on OpenStack that are happening on Mondays, right, at 11 Eastern. So
We should, hopefully, it will get that cemented into the schedule.
All right, thanks, Brian. I'm gonna have to drop. Thanks, Karina.
thank you, everybody.
Well
All
done.
right.
Thanks all.
Thanks, folks.
Thanks.